In today's competitive job market, data science roles are highly sought after. To succeed in an interview, it's essential to be well prepared. This video presents the top 25 interview questions commonly asked in data science positions. The answers provided will guide you in formulating your responses and showcasing your skills effectively. Whether you are a beginner or a seasoned professional, these insights will help you navigate the interview process with confidence. 1. What is the difference between supervised and unsupervised learning? Supervised learning involves training a model on labeled data, where the algorithm learns to map input features to the correct output based on provided examples. This type of learning is commonly used for tasks such as classification and regression. In contrast, unsupervised learning deals with labeled data, where the model attempts to identify patterns or groupings within the data without explicit guidance. Common applications include clustering and association tasks. The key distinction lies in the presence of labels. Supervised learning requires them, while unsupervised learning does not. 2. Explain the concept of overfitting and how to prevent it. Overfitting occurs when a model learns the training data too well, capturing noise along with the underlying patterns. To prevent overfitting, techniques such as cross-validation, regularization, L1 and L2, pruning, in decision trees, and early stopping during training can be employed. Additionally, using a simpler model, reducing the number of features, or increasing the size of the training dataset can help improve generalization performance. 3. What is the purpose of regularization in machine learning models? Regularization serves as a technique in machine learning to prevent overfitting by adding a penalty term to the loss function. This penalty discourages complex models that fit the training data too closely, which can lead to poor performance on unseen data. By introducing this constraint, regularization encourages the model to generalize better, ensuring it captures the underlying patterns rather than noise. Common forms of regularization include L1, lasso, and L2, ridge, which respectively promote sparsity and smoothness in the model coefficients. Regularization is essential for improving model robustness and reliability. 4. Describe the differences between L1 and L2 regularization. L1 regularization, also known as lasso regularization, adds the absolute value of the coefficients as a penalty term to the loss function. This can lead to sparse solutions, effectively performing feature selection by driving some coefficients to zero. In contrast, L2 regularization, known as ridge regularization, adds the squared value of the coefficients as a penalty term. This approach generally shrinks all coefficients uniformly, but does not produce sparse solutions. L1 is useful for models needing feature selection, while L2 is beneficial when dealing with multicollinearity or when all features are relevant. 5. How would you handle imbalanced datasets in classification problems? Handling imbalanced datasets is crucial to ensure that the model does not favor the majority class. One common approach is resampling techniques. You can use oversampling to duplicate instances of the minority class or undersampling to remove instances from the majority class. Another method is to use synthetic data generation techniques like SMOTE, synthetic minority oversampling technique. Additionally, employing cost-sensitive learning allows you to assign different weights to classes in the loss function. Finally, utilizing algorithms specifically designed for imbalanced data, such as ensemble methods like random forest or gradient boosting, can improve model performance. 6. What are some common data preprocessing techniques? Data preprocessing is essential for preparing raw data for analysis. Common techniques include 1. Data cleaning, removing duplicates, correcting errors, and handling missing values through imputation or removal. 2. Data transformation, normalization and standardization to adjust the scale of features, making them comparable. 3. Encoding categorical variables, converting categorical data into numerical format using techniques like one-hot encoding or label encoding. 4. Feature extraction, selecting relevant features or creating new ones to improve model performance. 5. Data splitting, dividing the dataset into training, validation, and test sets to evaluate model performance. These techniques enhance the quality of data, ensuring effective analysis and modeling. 7. Explain the difference between correlation and causation. Correlation indicates a statistical relationship between two variables, meaning they tend to move together. However, it does not imply that one causes the other. For instance, ice cream sales and drowning incidents may correlate during summer months, but this does not mean that buying ice cream causes drowning. Causation, on the other hand, implies a direct influence of one variable on another. Establishing causation often requires controlled experiments or longitudinal studies to rule out other factors and confirm that changes in one variable directly lead to changes in another. 8. How would you detect and handle outliers in a dataset? Detecting outliers can be achieved through statistical methods like z-scores or the IQR, interquartile range, method. A z-score helps identify how many standard deviations an element is from the mean, while IQR focuses on the range between the first and third quartiles. Once detected, handling outliers can involve several strategies. One option is to remove them if they result from errors or irrelevant data points. Alternatively, outliers can be transformed or capped, ensuring they don't disproportionately influence model training. Choosing the right method depends on the context and the importance of the data. 9. What is the purpose of feature scaling, and when should it be applied? Feature scaling is crucial in machine learning as it ensures that features contribute equally to the model's performance. Different features may have varying ranges or units, which can lead to biased results, especially in distance-based algorithms like k-means clustering or k-nearest neighbors. Scaling methods, such as normalization, min-max scaling, and standardization, z-score scaling, adjust these ranges. Applying feature scaling is particularly important when features are on different scales, such as age and income, or when using algorithms that are sensitive to data magnitudes. 10. Describe the process of feature selection and its importance. Feature selection involves identifying and selecting a subset of relevant features for use in model construction. The process typically includes several steps. 1. Understanding data. Analyzing the dataset to comprehend its structure and relationships. 2. Removing irrelevant features. Discarding features that do not contribute meaningfully to the predictive power. 3. Evaluating feature importance. Using techniques like correlation coefficients, recursive feature elimination, or tree-based methods to rank features based on their impact on model performance. 4. Modeling. Building models using selected features and assessing their performance. This process enhances model accuracy, reduces overfitting, and improves interpretability while decreasing computational costs. 11. What is the difference between inner join and left join? Inner join returns only the rows that have matching values in both tables involved in the join. This means if there are no matches, those rows will not appear in the result set. On the other hand, left join, or left outer join, retrieves all rows from the left table, along with matching rows from the right table. If there is no match, null values will be returned for columns from the right table. This makes left join useful when you want to retain all entries from one table regardless of whether there are corresponding entries in the other. 12. How would you optimize a slow-running SQL query? To optimize a slow-running SQL query, start by analyzing the query execution plan to identify bottlenecks. Use indexes strategically on columns involved in where clauses, join conditions, and order by statements, as they can significantly speed up data retrieval. Avoid select asterisk, and instead specify only the necessary columns. Refactor subqueries into joins where applicable, as this can improve performance. Additionally, consider breaking complex queries into smaller, simpler ones. Monitor database statistics and update them regularly to ensure the optimizer has accurate information for query execution. 13. Explain the concept of database normalization. Database normalization is a systematic approach of organizing data in a database to reduce redundancy and improve data integrity. It involves dividing large tables into smaller ones and defining relationships between them. The process typically follows several normal forms, each with specific rules. The first normal form, 1NF, ensures that each column contains atomic values, while the second, 2NF, and third, 3NF, normal forms address issues of partial and transitive dependencies. Normalization helps in minimizing duplication, making data updates easier, and ensuring consistent data across the database. 14. What are window functions in SQL, and how are they useful? Window functions are powerful SQL functions that perform calculations across a specified range of rows related to the current row within a result set. Unlike regular aggregate functions, which return a single result for a group of rows, window functions maintain the individual row identities while providing aggregate values. They are useful for tasks such as running totals, moving averages, and ranking data. By using window functions, analysts can derive insights from complex datasets without needing to write subqueries or temporary tables, simplifying SQL queries and enhancing readability. 15. How would you handle missing data in a SQL database? Handling missing data in a SQL database involves several strategies. First, identify missing values using SQL queries to analyze the dataset. Depending on the context, options include deleting rows with missing values if they are few, which minimizes data loss. Alternatively, imputation can be used to fill in missing values, using the mean, median, mode, or even predictive models based on other features. Another approach is to create a separate category for missing values. It's crucial to document the method used for transparency and reproducibility in data analysis. 16. What are the main differences between Python and R for data science? Python is known for its versatility and ease of use, making it a popular choice among data scientists. It has a rich ecosystem of libraries like Pandas, NumPy, and Matplotlib, which facilitate data manipulation and visualization. R, on the other hand, is specifically designed for statistical analysis and provides advanced data visualization capabilities through packages like ggplot2. Python has a strong focus on machine learning and deployment, while R excels in exploratory data analysis and statistical modeling. Both languages have their strengths, and the choice often depends on the specific needs of a project. 17. Explain the concept of vectorization in NumPy and its advantages. Vectorization in NumPy refers to the process of performing operations on entire arrays or subarrays at once, instead of using for loops. This approach leverages low-level optimizations for speed and efficiency. It allows for element-wise operations, broadcasting, and mathematical functions to be applied directly to arrays. One key advantage is the significant performance improvement, as vectorized operations are typically much faster than iterating through elements. Additionally, code becomes more readable and concise, making it easier to maintain and understand. This approach is particularly beneficial in data analysis and scientific computing. 18. How would you implement a k-means clustering algorithm from scratch? To implement a k-means clustering algorithm from scratch, follow these steps. 1. Initialize centroids. Randomly select k data points as initial centroids. 2. Assign clusters. For each data point, calculate the distance to each centroid and assign the point to the nearest centroid. 3. Update centroids. After all points are assigned, calculate the new centroids by taking the mean of all points in each cluster. 4. Repeat. Repeat the assignment and update steps until the centroids no longer change significantly or a set number of iterations is reached. This process divides data into k clusters based on similarity, allowing for effective pattern recognition in various datasets. 19. Describe the differences between Pandas dataframe and NumPy array. A Pandas dataframe is a two-dimensional, size-mutable, and potentially heterogeneous tabular data structure with labeled axes, rows and columns, allowing for easy data manipulation and analysis. It provides functionalities for handling missing data, merging, and grouping datasets. Conversely, a NumPy array is a homogeneous multidimensional container for numerical data, optimized for performance in mathematical operations. While NumPy arrays are faster for numerical computations, dataframes offer more flexibility and readability, making them more suitable for data analysis tasks where data types may vary or require complex operations. 20. What are some popular data visualization libraries in Python, and when would you use each? Some popular data visualization libraries in Python include Matplotlib, Seaborn, Plotly, and Bokeh. Matplotlib is great for creating static plots and provides control over every aspect of the figure. Seaborn builds on Matplotlib and simplifies complex visualizations, particularly for statistical graphics. Plotly is ideal for interactive visualizations, making it suitable for web applications. Bokeh also focuses on interactive plots and handles large datasets well. Each library serves different needs, from quick plots to intricate interactive dashboards, allowing for flexibility based on project requirements. 21. How would you approach an A/B testing problem? When approaching an A/B testing problem, first, define clear objectives and metrics for success. Identify the variables you want to test, such as different website designs or marketing messages. Randomly assign users into control, A, and treatment, B, groups to ensure unbiased results. Implement the changes in the treatment group while keeping the control group unchanged. Collect data during the testing period and analyze the results using statistical methods to determine if the differences are significant. Finally, interpret the findings to inform decisions about whether to implement the changes. 22. Explain the ROC curve and its significance in model evaluation. The ROC, Receiver Operating Characteristic, curve is a graphical representation used to assess the performance of a binary classification model. It plots the true positive rate, sensitivity, against the false positive rate, 1 specificity, at various threshold settings. The area under the ROC curve, AUC, quantifies the model's ability to discriminate between positive and negative classes, with a value of 1 indicating perfect classification and 0.5 suggesting no discriminative power. A higher AUC value reflects better model performance, making the ROC curve a vital tool for evaluating and comparing different classifiers. 23. Describe a situation where you had to clean and preprocess a large, messy dataset. What steps did you take? When faced with a large, messy dataset containing customer reviews for a product, I began by assessing the data for missing values and inconsistencies. I removed duplicates and filled missing entries with appropriate methods, such as using the mean for numerical data or the mode for categorical data. Next, I standardized date formats and converted text to consistent casing. I then used regular expressions to clean up any unwanted characters in the text fields. Finally, I employed techniques like tokenization and stemming for text preprocessing, ensuring the dataset was ready for analysis and modeling. 24. How would you build a recommendation system for an e-commerce website? To build a recommendation system for an e-commerce website, start by collecting user data, such as purchase history, ratings, and browsing behavior. Choose between a collaborative filtering approach, which leverages user item interactions to suggest items based on similar users, or a content-based filtering method that recommends items based on their features and the user's past preferences. Hybrid systems often combine both methods for better accuracy. Implement algorithms like matrix factorization or nearest neighbors, and continuously evaluate the system's performance using metrics like precision and recall to enhance user experience. 25. Explain the concept of ensemble learning and give examples of ensemble methods. Ensemble learning is a machine learning paradigm that combines multiple models to improve the robustness and accuracy of predictions. This technique leverages the strengths of different algorithms to produce a composite model that often performs better than any single model. Common ensemble methods include bagging, where multiple versions of a model are trained on different subsets of the data, like random forests, and boosting, which sequentially trains models, focusing on the errors of previous ones, like AdaBoost and gradient boosting. These methods help reduce variance and bias, enhancing predictive performance. In exploring the top 25 data scientist interview questions and answers, we've provided you with valuable insights to enhance your interview preparation. Mastering these questions not only boosts your confidence but also equips you with the knowledge to impress potential employers. Remember, each interview is an opportunity to showcase your skills and passion for data science. If you found this video helpful, please give it a thumbs up and consider subscribing to our channel for more content like this. Your support helps us continue to create valuable resources for aspiring data scientists. Thank you for watching.